Welcome to lesson 21, problem number 1, where we are factoring. And keep in mind that as we are factoring in this lesson, we are reviewing all the different types of factoring problems that we've done. Remember, and just to summarize, our first step in factoring is always the greatest common factor. Then we look at how many terms we have and we use that as a clue for our approach. And the third thing we do is we always check to see if we can factor again. So let's get started. Number 1A, there is a GCF. It is 7x, and we can take out x to the first and y to the first. In the parentheses, we are left with xy squared. And if you forgot how to do any of this, please email me or go back to earlier lessons. Okay, so right now, if you were to test it, you could multiply through and say, yep, I would definitely get 7x squared y to the third. So I'm on a good track right here. Okay, and then all we need for the next part is plus 3 because 7xy times 3 is 21xy. Okay, we have factored completely. Okay, there's nothing else, by the way, we can do with that, which is why we are done. Okay, let's go to the next one. Here, the greatest common factor is 7. So we take out the 7, and we are left with d squared minus 10d minus 11. Now we think, okay, there's 3 terms. So when there's 3 terms and the leading coefficient, in other words, the number in front of the squared term right here is simply 1, even though it's not written, we can simply think of it as an AM problem. We're going to have to figure out what adds to negative 10 and multiplies to negative 11. So knowing when you have an AM problem where you're adding to the middle term and multiplying to the last is super helpful in factoring. So the two numbers that multiply to negative 11 that also happen to add to negative 10 are negative 11 and positive 1. Sorry, that was a negative 11 there. It looked more like a 4 though, but it's negative 11 and positive 1. Okay, so our final answer, you cannot drop that 7. That 7 has to stay. So your final answer is going to be simply 7 times d plus 1 times d minus 11. And no, it makes no difference whether you put this or this first, as long as you have the d plus 1 and the d minus 11. Okay, let's go to the next one. GCF is 2. So we have 2 times j squared minus 121. So now all we have to do is say, all right, there's 2 terms. With 2 terms, we're always looking for the difference of 2 squares if it can factor again. Since j squared is a perfect square and 121 is a perfect square, we write the 2 again. The 2 has to be rewritten. And then we simply take the square root of the first, which is j, the square root of the second, which is 11, and then we do the same exact thing, but instead of a minus, we put a plus. Okay. Feel free to multiply that out and see that you would get back to that original. Okay, the next one. There is no greatest common factor between these 2 terms. So it's simply 2 terms. There was no GCF. So we're going to take the square root of the first minus the square root of the second, and then it's going to be the square root of the first plus the square root of the second. Okay, that's it. That's everything we have to do. All right, E. It looks to me like there's no greatest common factor because there's x's and y's, but not a common factor for every single one of those 3 terms. Now, when it's this messy, I'm already thinking, let's see if it's a perfect square trinomial, because that would make it a little bit easier to factor. And sure enough, if you take the square root of 81x squared, it's 9x. If you take the square root of the last term, it's 5y. If you multiply these 2 together, you would get 45xy. If you double it and it's that middle term, we know it's a perfect square trinomial. So 9x times 5y is 45xy, doubled is 90xy. Yep, we definitely have a perfect square trinomial. So now what we're going to do is I'm going to write it as 2 parentheses first, but then just to make sure you see. So it's going to be the square root of 81x squared, so 9x, plus the square root of 25y squared, so it's going to be plus 5y, and then the other parentheses will be as the exact same thing, 9x plus 5y. And notice that perfect square trinomials can be written in this form. So we're done. Okay, and feel free to multiply it out again if you want to see that it really works. Okay, this next one, there's no greatest common factor. And this is one where we can't just do AM. Nope. We would if that 14, that the coefficient on the x squared term was a 1, but it's not. It's a 14, making our lives much tougher for this problem. So what we're going to do is we're going to split the middle term. So we start by a times c, which is negative 28. We find two numbers that multiply to negative 28 and also add to b, which in this case is 3. Those two numbers are a positive 7 and a negative 4. And then what we do is we literally split that 3x into two terms. Because remember, 3x is the same as 7x minus 4x. So we have literally split that middle term. Okay, so now that we've done this, now we group 2 and 2, and we take out the GCF from each. So it's 7x, so this becomes 2x plus 1, and then there's no GCF other than 2. There's no letter, no variable that goes into both terms, but we can take out a negative 2. And if this third term, when you split the middle term, it turns into 4 terms, and if the third one right there is a negative, we always factor out a negative. So that's why I'm factoring out negative 2, not positive 2. So it's negative 2, and then we have 2x plus 1. We know we are definitely doing great if these two parentheses match. So pat yourself on the back on that one. And now all we're going to do is take our GCF of 2x plus 1. Make this look a little bit more like a parentheses. So 2x plus 1, just want to make that look a little bit more like a 1. It was kind of merging together. So it's 2x plus 1. And then what's left over is 7x minus 2. And we're done. Okay, let's go to G. There is a greatest common factor. There's also an issue that not everything is in order. So I'm going to rewrite it as 12x squared minus 26x plus 12. Okay, so now that we have it rewritten in standard form, now let's look for our greatest common factor, which in this case is just 2. So we have 2 times 6x squared minus 13x, and then just plus 6. So now, because this number is still, the number in front of x squared is still not 1, we have to do the splitting the middle term process. So let's make a little more space for ourselves right here. And we'll use some of this space at the bottom to do some of this work. So what we have to do is we're first going to do the 6 times the 6, a times c, and we get 36. The two numbers that multiply to positive 36 add up to negative 13 are negative 9 and negative 4. This 2, I'm going to come back to that and just make sure we remember to put that in our final answer. But right now, I'm only going to focus on this part right here. So I'm going to split the middle term, 6x squared minus 9x minus 4x plus 6. And then I'm going to group 2 and 2, 2 and 2. So from the first two, the greatest common factor is 3x. So I have 3x times 2x minus 3. And then from the second two terms, I have a minus 2 as my GCF. And I once again have 2x minus 3. So our final answer for G, I'm going to write our final answer in another color. And you know what? We're going to fit it in right about here because we'll kind of make some space there. So our final is going to be, this 2 has to be rewritten. So it's 2. And then the 2x minus 3 is 1 GCF. And the remaining part is the 3x minus 2. So this right here is my final factored form. Okay, let's go to H. And for H, what we're really doing is we're going to say there are 4 terms. So when there's 4 terms, we're looking to group 2 and 2. So from those first 2 terms, we're going to take out the greatest common factor of 5. And so we have 5 times x minus 4y. And then from these 2 terms, we have the greatest common factor is going to be a positive 8. And then we have x to the first, y to the first. Now in these parentheses, hopefully we'll get x minus 4y because that always tells you that we did it right. And sure enough, we get x, and then we need a minus 4y. And thank goodness our two parentheses match. And so our final answer is simply that common factor of x minus 4y, and then the remaining factor is 5 plus 8xy. That's a y. Let's redo that y just to make sure you can see it really clearly. Okay, and we're done. Great job.